topic that I'm going to cover today is fertilizer formulations for turfgrass. It's a little bit different in the turf world than it is in crop production in terms of the amounts of the macronutrients, especially that we need. And so I thought I would go ahead and just do a bit of an overview, first of all, of turf nutrition from a specifically turfgrass point of view, plant nutrition from a specifically turfgrass point of view. And this is something which I always emphasize every time I talk about it. And I'll tell you what, I've got students who get this wrong every year on tests. Remember, plants get their carbon, their hydrogen, and their oxygen from the air and water. So carbon comes from CO2, right, in the atmosphere. Hydrogen and oxygen usually come from water. And that's the vast majority of the mass of a plant, right? When we talk about feeding plants or fertilizing plants, giving them the nutrients they need, we usually talk about NPK, right? Because that's what plants get out of the soil in the largest amount. But that's not actually what the bulk of the elements that plants need to grow are. But anyway, let's forget about CH&O right now, because NP and K are what we add in fertilizers. Usually, plants get these dissolved in water from the soil. Now, with turf, we also have the special, and with other crops too, you can get some absorption of nutrients through the foliage, but we're going to talk mostly about granular fertilizers here. And so these are going to be things that have to get into the soil solution and be absorbed through a plant's roots. Now, for turf, okay, the nutrients that are needed in the largest amount, other than carbon, hydrogen, and oxygen, are nitrogen, and then potassium, and then phosphorus. And this is where turf is a little bit different from a fruit crop or a vegetable crop or a grain crop, because in those, you need a lot more phosphorus than you do when you're growing turf, okay? And we'll talk about that in a minute. So I'm going to talk about nitrogen, K, and P, all right? We'll talk a little bit maybe about secondary and micronutrients, but since this is a fertilizer formulation, we're going to lean heavily into nitrogen for the rest of the talk, okay? It is the nutrient that is most likely to be deficient in a turfgrass just because it's the one that's added in the greatest quantity. Nitrogen usually makes up about 2.5 to 5% of turfgrass tissue by weight. That can be more, especially in say a golf course turf situation where you're heavily fertilizing. But this is one of the big three, right? Fertilizer elements, and it's still only a minor component, compared to carbon, hydrogen, and oxygen. But it's vital, right? You can't have a living thing, at least on Earth, without nitrogen. Nitrogen is in the amino acids, which are used to make protein. It's in the nucleic acids, which are used to make DNA and RNA, key part of chlorophyll. And this is why, of course, one of the major nitrogen deficiency symptoms is chlorosis, right? Yellowing of the plant because not enough chlorophyll there, absorbing the yellow, red, and blue light, and producing that green color. This right here, I've shown it before many times. I'm not going to spend a whole lot of time talking about quantities of nitrogen that we recommend for different grass growing situations. But for the popular grasses that we see grown in the state of Alabama, these are my current recommendations for pounds of actual N per 1,000 square feet of turf per growing season for these different grasses. Okay, so for grass lawns, 3 to 5, athletic fields, you can get really high, and golf courses on a putting green, depending on use. And you can see the numbers here: Seashore Paspalum, St. Augustine, require a fair amount of nitrogen. Zoysia grass less. You can have a nice zoysia lawn with like 1 or 2 pounds of nitrogen per year, and that's it. Centipede, of course, for those of us who deal with centipede grass, we know that it's not a grass that likes a lot of nitrogen. So 0 to 1 pound maybe per 1,000 per year is all that needs. And then for cool season grasses, if you're up in the Tennessee Valley growing tall fescue, you want to put this on spring and fall rather than in the summer, because that's when the cool season grasses are growing about 2 or 3 pounds in a year, and overseed ryegrass a pound or two, maybe a little bit more if you've got it on like a football field or a soccer field that's getting a lot of traffic. Okay, phosphorus I'm going to touch on, and with phosphorus, actually, we're usually more concerned about over applying it than a deficiency, right? If you have been binging these webinars on the commercial hort page, you've probably heard a lot of us specialists and agents say how important it is to get a soil test, right? And that's really what's going to let you know how much phosphorus you need. And don't apply more, because excess phosphorus, when it gets into surface water, it is often the limiting element for growth of algae, and that can cause eutrophication and all of those problems when you have depleted oxygen in surface water. It's mostly through runoff that phosphorus moves. Situations like this, we've probably all seen stuff like this happen before. Anytime you've got salt particles moving off site, if there's phosphorus attached, it can get into surface water and cause stuff that looks like that. Okay, we're going to come back and talk about phosphorus just a little bit more, but remember this, okay? Phosphorus doesn't generally leach, especially not from a loamy or a clay soil. On straight sand, if you put a lot on, you can get it to leach, but that's kind of a specialized problem. And so remember that phosphorus does tend to accumulate in the soil. If you've ever built a house on a piece of property that used to be a cotton field, for example, or a row crop field in general, you're probably going to be okay on your phosphorus levels in that soil for a while because of all of the PA applications that have been made, while that was cropland. So again, follow your soil tests, okay? What you'll find is these days, many turfgrass fertilizers don't have any phosphorus in them at all, and that's because the phosphorus requirements for turf are very low. We're not trying generally to produce a flower or a fruit when we're growing turfgrass, okay? We're not out in Oregon growing, Kentucky bluegrass for seed. We're here in the Southeast growing, zoysia grass for egg lawns. So our phosphorus levels that we need to keep turf healthy are pretty low. And so to prevent runoff issues, and also to deal with states like especially Florida and the states that border the Great Lakes that have put restrictions on the amount of phosphorus you can use in the landscape, a lot of fertilizer companies are just going to making their turf formulations, specific, fertilizers for use on turf grass, phosphorus free. And you'll see that a lot. Used to be, this would be a very low number, but not zero in a turf fertilizer, but now it is often zero. Okay. Okay, like I said, in potassium, in turf, potassium is the element that we're going to need in the second highest quantity besides nitrogen. Typical K levels in turfgrass tissue are maybe 1 to 4% in dry weight. Now, K is interesting because it's not really a constituent of any of the molecules that are really important for plant growth. What K does is plants use potassium ions to regulate water content in cells. Famously, potassium concentration in the guard cells around plant stomates is used to either make those swell up and therefore open the stomate, or lose water and therefore close the stomate. So potassium levels are real important in a plant to allow it to regulate how much water it's losing and the water content in cells generally. And of course, that's really important in turf grasses and other herbaceous plants because it's the water pressure inside the cells that causes those plants to stand up straight. You lose water, you wilt. So potassium deficiencies are linked to stress tolerance, or the lack of, I should say, stress tolerance in plants, especially drought stress and maybe freezing tolerance. Okay, there's been some work which has led to, especially in cool season grasses, occasionally some data showing a link between potassium and winter kill. Not so much in the warm season grasses though, but it is true that winter kill is often the result of two things, right? Desiccation, or the plants just drying out in the cold, dry winter conditions, plus straight up cold damage. Okay. And so, you probably do want to make sure that you soil test and make sure that you have a sufficient level of K for your turf, but there's very little evidence that piling on more K above that sufficiency level that our soil tests are calibrated to really helps winter hardiness any extra. Okay. So it does seem to be a little bit stronger of an effect in cool season grasses, very linked to N fertility as well. Okay. However, you will still see stuff like this on the market. So here's a fertilizer that's called a winterizer fertilizer. What is it? It's 22014. Now this is kind of an older picture because, nowadays all turf fertilizers, or I shouldn't say all, but a lot of turf fertilizers are phosphorus free anyways. But this one right here, a little bit more phosphorus, sorry, a little bit more potassium, no phosphorus, a little more potassium than your standard turf fertilizer, but yeah, okay. Enough said about that. One last thing about K is that we used to think, well, you know what, K, maybe you don't need a whole lot of it, but at least if you don't, if you put a little bit too much out, you're not going to do any harm. Starting in the mid-teens, we started to see some work come out. Now, this is on a putting green, okay, so this is really specific. But we started to see this disease called pink snow mold, also known sometimes as microdocium patch, getting more severe over time when you put a lot of potassium out, okay? So here's, the progression of this disease on a green with no extra K, or with calcium sulfate. And the reason for that is to control for the sulfate, because the K was put out as potassium sulfate. And you can see here a little bit of increase in disease over time. This does happen if you don't spray fungicides, but look at this huge increase over time when you put out K. Very interesting. So maybe it's not a no harm, no foul anymore, at least in the context of disease on a putting green. All right. So now let's real quick go over formulations returning to nitrogen, because that's what we're going to be adding the most to soil. When you look at a label on a fertilizer, you're going to see a couple of words or phrases, which I think we need to go over. So it's going to tell you how much ammoniacal or urea nitrogen there is. This is readily available, dissolves in water right away. As soon as that prill gets wet, the urea is going to dissolve, ammonium is going to dissolve. So if you put out ammonium sulfate or urea, that's going to be readily available to plants. Water soluble nitrogen is other very quickly available nitrogen. And then water insoluble nitrogen, this is going to be generally your slow release fertilizer. So whether it's an organic fertilizer or something like urea that's been reacted to form a urea formaldehyde long molecule, or urea that's been coated with sulfur or with plastic. These things are not going to be readily available to plants and will be slow release. Okay, so here's a good example of this. Even organic fertilizers generally do have some soluble N in them, and this is a good example of that. So here's an organic fertilizer made from composted turkey litter, hydrolyzed feather meal, and sulfate of potash. So it's 4% nitrogen, but 0.4% of that is in fact soluble in the form of ammonia. Okay, so even though 90% of the N in this product is slow release, there is a little bit of readily available nitrogen there. Is that enough to give you a quick green up? Depends how much of this stuff you slather onto the grass, doesn't it? People say, oh, well, I need a lot of N, so I need a high nitrogen analysis, right? Not necessarily. I mean, you just need less of a high analysis in fertilizer to get the same amount of N as a low one, right? I mean, you could put out a pound of N with this stuff that's 4% nitrogen, you just need a lot more of it than if you put out urea, which is 46% nitrogen. You'd need about 10 times more of it, right? Whether you can physically do that, that's another thing as well. But you don't always need to just immediately go for a higher N analysis to get more nitrogen. This slide here is an overview of some common turfgrass N sources, and this is broken down into chemically, whether they're inorganic, natural organics, or synthetic organics. Now, this chart is using the definition of organic, which is the chemical definition of organic, which is a molecule that contains carbon. Okay. The general public's definition of organic would be what's listed here as natural organics. So things like manures, composts, your biosolids, which activated sewage sludge is usually these days called biosolids for reasons which may be obvious. Think milorganite. That's probably the most famous turf example of that type of a fertilizer. But we got a million different ureas and coated ureas in the synthetic organic. And whether or not these are fast or slow release really depends. Urea by itself is very soluble in water, which is why it's listed here as having a high burn potential, right? You put out too much of that, it dissolves in water on the leaf, especially, it's going to burn the plant. But if you put a coating on it, like a sulfur coating or a plastic coating, or if you react it into a long chain polymer, then it becomes slow release and you don't have a burn potential. Inorganic forms of nitrogen, like ammonium sulfate, also tend to be very soluble in water, so they have a high burn potential. Okay, but one thing which we'll talk about next is slow release fertilizers generally don't release as well when the temperature is low as when it's hot. So right now, you could put out milorganite, you could put out a polymer coated urea, you could put out osmocote, and it's going to release probably about as fast as it ever will, right? Because it's as hot as it's going to get for the whole season right now. But put those out in December and January, you're not likely to see a big response. Like say you have a ryegrass overseed or something like that. You probably want to put out mostly soluble then on that if you're fertilizing it in the cooler months. Okay. Now, most retail lawn fertilizers, for those of us who are dealing with the home lawn market, they have usually a mix of soluble and slow release N because they want to have it both ways, right? They want to put out a product that'll give you a quick green up, but then also sustain that green up. Okay, and so this is a good example of such a product. This one also has iron in it, and you'll see lawn fertilizers or turfgrass fertilizers in general often contain iron. If there is a micronutrient that is going to be deficient in turf, it's probably going to be iron. Plus, grass always greens up when you put iron on it. And that really doesn't correlate with a soil test or a tissue test. It just gets greener when you put iron on it. So that's another reason why fertilizer companies do this. And notice the analysis here is 2905, modern turfgrass fertilizer. Oh, and here's another thing. This is convenient, right? They always tell you how many square feet a bag covers, which makes it easier to figure out how much you need to put in the spreader, right? So that's, if you know the size of the patch of turf you need to fertilize, then all you got to do is figure out, okay, 42 pounds covers 15,000 square feet with this product. So we know that. So then we can pretty easily calculate how much we would need for like 1,000 square feet. It would just be 42 divided by 15, right? Okay. Now, when we get into slow release fertilizers, we have a lot of different options. One option is a coated urea. Okay, this is, in this part of the world anyways, probably one of the more famous ones because comes out of Silicaga, Polyon, right? A polymer coated urea. You put a plastic coating on the urea prill, and that prevents water from getting to that urea quickly and dissolving it. Water still does get through, right? You want water to get through that coating so that it can dissolve that urea, and then that, water with the urea dissolved in it can diffuse back out, but you want it to do it very slowly so you get a slow release fertilizer. So instead of looking at something like this, right? So this picture here is grass that's been fertilized with urea, okay? very quick green up. You want something that happens much more slowly. So in the time we have left, I'm just going to go through this really fast. I know you're not going to retain all of it, but I'm going to show you some pictures of these different slow release fertilizers as well. And we'll talk about this. So let's talk about, first of all, things that are coated urea products for the most part. Okay. It actually goes a long way back in some of these cases. Oh, I'm sorry. This is mixing both. Don't worry about it. Let me highlight first the coated product. Sulfur-coated urea. Commercial production began in the early 1970s. The patent, I think, was issued in 1961. Generally has a yellow color. Polymer-coated ureas. Polyon was in the 90s, multi-coat in the 90s. Man, just more of this stuff keeps coming out, okay? But that's not the only way that you can make nitrogen slow release. You can also make it slow release by actually reacting urea with usually formaldehyde in order to make a very long molecule that takes a long time to break down and actually release urea. And I'm going to go back a little bit, and that's what this is right here, urea formaldehyde. This is probably the oldest slow release chemical fertilizer, you know, not a natural organic. Obviously, the oldest is poop, but the oldest chemical slow release fertilizer is probably urea formaldehyde. Started production in the United States back in the 50s. Okay. What is it? If you make a cartoon of it, it's really simple. You have a urea molecule linked to another urea molecule with a formaldehyde molecule in between. And depending on the manufacturing process, you can make these chains pretty dang long. And generally speaking, the longer they are, whoops, the longer it takes to release. Okay, because these chains generally can only be broken down from the ends. It takes microbial activity to do this. So the longer the chain, the longer it'll take to release all of this urea into a soluble form. And these are just some brand names and relative chain lengths of different polymer type fertilizers like this. Okay. Coated fertilizers, I'm going to accelerate, but this is generally what happens with a coated fertilizer. You put it out, water diffuses through the coating, dissolves the urea that's, you know, in the middle of the coating, diffuses back out, and then hopefully you'll have a coating that is biodegradable eventually. Some of these coatings are more biodegradable than others. So sometimes, especially in turf, you know, that's been heavily fertilized with a coated fertilizer, you can still see those collapsed coatings after a long time. Sulfur coated urea, we mentioned this. This right here is kind of a cartoon of a sulfur coated urea prill. You've got urea there and then sulfur around it, and usually some kind of a wax sealant. It doesn't have to be there, but it is often there over the top. The thing you got to remember is, for this to work right, that coating has to be uniform on every piece of urea, and it has to be intact. So in the turf world, right, a major thing that will make a slow release fertilizer not slow release anymore is running over these prills with a lawnmower and breaking them. And that's what's called catastrophic release from here. Usually you get better diffusion through these coatings when it's hot than when it's cold. So these things do release faster when it's hot than when it's cold. And we do need moisture. Duh, right? We're trying to dissolve a prill of urea inside that coating in water. So we got to have water present. A lot of companies say they need only 5 or 6% soil moisture to activate release. I'd probably be more comfortable with like 10% personally, but you know, that's just me. So we need to have water present. Okay, coating thickness determines the longevity and the release rate with most of these things. Hopefully that's obvious. If you want to look at this chart for a little while longer, you can come back and watch the archive and maybe pause it here. Because I wanted to get to this, which is just some data from a while ago, but looking at when you can expect growth from different products. So the red dots here are straight up urea, very soluble, and we see an increase in the color of the grass right away, just after a couple of days. But it doesn't last all that long. Lasts about 3 weeks before it starts to decline. Okay. Same thing if you add a urease inhibitor to there. But if you put out a slow release polyon, it takes about a month before you start to see a color difference, but it stays a lot longer. And that's what we want, right? And then bottom here is that's just unfertilized turf. Okay. Organic slow releases. The release is also varies with temperature and moisture, and this is because the organic matter is being broken down by microbes that live in the soil. So anything that makes the microbes that live in the soil grow faster generally makes organic fertilizers release their nitrogen faster. Anything that reduces that makes it slower. Okay. Bottom line, exact formulations always vary. And you should get a soil test. If you have any questions for me or anything like that, here's my contact info. And here is the direct URL to the Auburn University Soil Testing Lab, where you can find all the forms that you need to get your soil test started.